Hello everyone. So let's see some question from virtual work and impulse momentum principle. So this is question number 1. So you can see a spherical ball of weighing 2 kgs dropped from height of 4.9 meter onto an immovable rigid block as shown in the figure. If the collision is perfect elastic, then what is the momentum vector of the ball in kg meter per second just after impact? Take the acceleration of the gravity is 9.8 meter per second and option have been around round off to 1 decimal of the place, correct? So this is a question. So you can see here we have a ball, and this ball, if it drops, then obviously this ball can collide with this inclined surface, yes or no? So if I say the initial velocity of the ball just before the collision, can I say this is u1, and this u1 is nothing but, simply you can say this is u1. Is it clear? And u1 is nothing but, it can be written as square root of 2gh, and obviously here we have g, which is 9.8, and h is given here how much? This is 4.9 meter, correct? So after simplifying this you will get this is equal to 9.8 meter per second. So this is the velocity just before the collision of the this ball on the inclined surface. And let us suppose after collision, if this ball can move along this direction with velocity v, we don't know the velocity of this, yes or no? But if I draw a line which is perpendicular to this inclined surface, and you just say, first I am removing this, and you can see if I draw a line which is perpendicular to this inclined surface, it is looking like this. Is that clear? Yes, like this, correct? So obviously if this is 30 degree and this is perpendicular, so can I say this angle is nothing but this is 60 degree, yes or no? And similarly you can see here we need to find this angle. So obviously if I draw a line parallel to this, if this is 30 degree, then this must be a 30 degree, and if it is 30 degree, then ये angle क्या होगा? This is 60 degree, and after that you will get this angle is 30 degree. So I hope you will understand why I am writing this angle is 30 degree, yes or no? This angle is 30 degree, and the velocity of the ball before collision is nothing but, it can be represented like this. And suppose if I say this is u, so, and after collision, if I assume this ball is moving somewhere here, and I don't know at what angle this ball can move at with what velocity. So let's say if this angle is theta, this velocity makes an angle theta from this normal axis. Let's say this is normal axis. Yes or no? Correct. So first we need to find out this velocity, and once we get this velocity, then obviously we need to resolve this force along the horizontal axis. Yes or no? Along this direction. And similarly you need to find out velocity along this direction. This is our main objective. And once we get this velocity, then obviously we can write what is the velocity vector. Is that clear? So let's see how to solve this question. So if I say, if this is a perfect elastic collision, if we assume this is a case of perfect elastic collision. Perfect elastic collision. So for this, simply can I write this is E is equal to 1 or E is equal to 1. And what is the E? This is coefficient of restitution, which is nothing but this is the ratio of velocity of separation. Velocity of separation over velocity of approach. Velocity of approach. And obviously the velocity of approach is nothing but this is u, and the velocity of separation is nothing but v. Is it clear? V and u. So can I say v velocity of separation? Velocity of separation is nothing but, and yes, first we need to write, here I am writing along the normal direction, correct? Velocity along the normal direction. Simply if I say, if I write this equation, impulse, momentum, and you see one more thing, this is line of collision. Is it clear? Simply can I say this is line of impact. This is line of impact. And if I apply this expression, this concept along the line of impact, so obviously we know that the velocity, the approach velocity, let's say approach velocity along the line of impact is nothing but, can I say this is u cos 30 degree? Yes or no? Because this is a line of approach, and if you resolve this velocity along this line of approach, then you will get u cos 30. And similarly, velocity, this is separation velocity along the line of approach, if I say, then can I say this is nothing but this is, and if you take this the component of this velocity along the normal axis, then can I say this is v cos theta, and from this concept can I say u cos 30 degree is equal to v cos theta? Yes or no? So from this we can write v cos theta is equal to, u is given already, that is 9.8 into cos 30. So let us take, this is our equation number 1. This is equation number 1. Similarly, if I apply the principle of conservation of momentum, or we can say linear momentum, then simply can I say this is pi, this is nothing but this is pf. This is pi is a initial momentum, pf is a final momentum. So what about initial momentum? And here I am writing along the inclined surface. Along the inclined plane, yes or no? Along the inclined plane means ये जो इंक्लाइंड प्लेन आप देख रहे हो, इसके अलोंग अगर मैं यहाँ पे कंजर्वेशन ऑफ मोमेंटम अप्लाई करूं, तो सिंपली कैन आई से दिस इज नथिंग बट दिस इज पी आई इज इक्वल टू पी एफ. If this is pi is equal to pf, then simply can I say pi is nothing but this is m u sin 30, correct? If you take its component along the tangential direction, then obviously you will get this value. This is u sin 30 degree. Yes or no? And similarly इसका अगर मैं एक component लूंगा तो मुझे क्या मिलेगा? This is also this is also a sine component, that is mv sin theta. So this is cancelled out with this. So simply can I say v sin theta is nothing but u sin theta, and u is nothing but this is 9.8 sin 30. Yes or no? And let us take this is equation 1. So from these two equations, we can easily determine velocity, because here we have two unknowns, that is velocity and theta. And by the use of these two equations, you will get the theta and v. So if I divide equation 2 with equation 1, so simply can I say v sin theta over v cos theta, this is equal to 9.8 sin 30 over 9.8 cos 30. Yes or no? So this is cancelled out with this is cancelled out with this. Yes or no? So simply here we get tan theta. Sorry, why I am writing like this? This is cancelled out with this. So simply here we can get tan theta is equal to tan 30 degree. So after solving this, here we get theta is equal to 30 degree. Yes or no? And once we will get theta, so by using any equation, let's say suppose from equation 1, we get velocity. Yes or no? And velocity is nothing but if I say yes, okay, so now I am using equation 2, not equation 1. कोई सा भी यूज कर सकते हो, it is not necessary. So equation 2 is nothing but this is v sin theta is equal to 9.8 sin 30 degree. Yes or no? Sin 30 degree. So simply can I say v sin theta, theta is 30 degree, this is 9.8 sin 30. So this is cancelled out with this. So simply here we get velocity after collision. This is nothing but this is 9.8 meter per second. So after getting this velocity as well as theta, now can I, if I represent, you can say this is a inclined surface. Yes or no? And obviously if I draw its perpendicular axis, then it is looking like this. And if I draw velocity component, then you can see it is looking like this. And initial velocity, that is velocity before collision, it can be represented like this. And this is velocity after collision. So this is v and this is u. And obviously it makes an angle 30 degree from this. And here we have this is I direction and this is j direction. Yes or no? And obviously you know this is 30 degree, which is already given, and we found this angle is 30 degree. Yes or no? So now we need to resolve this velocity along this direction. Yes or no? And along this direction. So can I say this angle, this total angle is nothing but this is 60 degree. Yes or no? 30 plus 30. So if I write this component velocity along x direction, so simply we can say this is nothing but this is v sine, and let's say this is phi angle, so sine phi. And similarly if I write this component which is vy, so simply can I write this is v cos phi. Yes or no? So the velocity vector is nothing but, can I say this is v sin phi I cap plus v cos phi j cap. Yes or no? Why? Because its y component is cos phi. Yes or no? So velocity vector is nothing but v is given, that is 9.8 sin 60 I plus 9.8 cos 60 j. And if you simplify this expression, then you will get 17 I plus I'm not calculating, this is 9.8 j. And yes, 9.8 j. And yes, actually this is velocity this is velocity vector, not this is 9.8. Actually we need to write final momentum, actually, correct? We need to determine final momentum. Let's see. What is the momentum? You can say here, what is the momentum vector of the ball? Yes or no? And suppose, suppose if you want to find, suppose if you want to find its velocity vector, so by the use of this, you can easily determine yes or no. So this is nothing but 9.8 sine 60i plus 9.8 cos 60j. Yes sir, this is velocity vector, but in this question we need to find out momentum, final momentum. So simply you multiply with this mass with velocity vector. So simply here we get mass is already given, that is 2 kg, 9.8 sine 60i plus 9.8 cos 60j. Yes or no? So with the help of this you can find out the final momentum, yes or no? And obviously for determining final momentum you need final velocity vector, yes or no? So now if you multiply with this, then simply you will get 17i. I'm not calculating, you just calculate this, 70i plus 9.8j. Is that clear? So this is the correct answer. So let's see which one is the right choice. Yes, option C is the right choice. Is that clear? So like this you can solve this problem. Okay, so let's see another question. This is, suppose this is question number 2. Is it a homogeneous uniform block of mass 1 kg, height h is equal to 0.4 meter and width b is 0.3 meter. You can see the height is given, that is 0.4 meter, and this width is also given, that is 0.3 meter. Is pinned at one corner. You can see at this corner it is pinned. Let's say this corner is A. Pinned with one corner and placed upright in a uniform gravitational field 9.81 meter per second square, supported by a roller. This is the roller support. You just see this block is putted over this roller support. This is not integrated part of this block. Yes or no? Simply ये जो block है इस roller के ऊपर रखा हुआ है. It just provide a support. Is that clear? In the configuration shown in the figure, a short duration force F produced, you can see this force is applied, and impulse, मतलब यहाँ से कुछ टकरा रहा है जो कि एक impulsive force अप्लाई कर रहा है. Is that clear? Is applied at a height of d, that is 0.3 meter. This is also given, this is 0.3 meter from the bottom as shown in the figure. Assume all joints to be frictionless. The minimum value of IF required to topple the block is, correct? So let's see, suppose if I say its center of gravity is situated somewhere here. Is that clear? Which is lying on at a distance of, obviously this is half of 0.3, so can I say this is 1.5 meter, and this is half of h, that is 0.2 meter. Yes or no? So from this can I say this is, let's say this is r. So simply from this we can write r is nothing but this is square root of 0.15 square plus 0.2 square, and after simplifying this you will get this is 0.25 meter. Yes or no? Okay, so after this you can see what you need to find out IF. Yes or no? So now let's see due what is the IF? Impulse. So due to impulse, can I say due to impulse IF we get a force F. Yes or no? इसकी वजह से क्या force act हो रहा है? Small f. Yes or no? So simply can I say F is nothing but it is causes due to impulse force IF, and so as you see here IF is nothing but this is angular impulse, correct? Because when you apply force this, then obviously this body can rotate. So due to this I can say this is nothing but this is called as angular angular impulse. Correct. So angular impulse is nothing but, can I say this is uh, moment of inertia. Angular impulse is nothing but this is moment of inertia into d. Is it clear? Moment of inertia into d. And moment of inertia is nothing but, here we take moment of inertia about a. So let's see, this is equation 1. And now we can also say this impulse is equal to change of angular momentum. Yes or no? Change of angular momentum. So angular impulse is nothing but this is equal to change of angular momentum. And obviously angular momentum is represented by Li. So this is Li minus Lf. And what about Li? Since this is stationary, so simply we can say Li is equal to 0. Yes or no? So here we have only Lf. Is it clear? So you can see here Ia is nothing but this is moment of inertia about this corner point A. So first we need to find out this Ia. So if I see, you can see here, this is a block. Yes or no? And this is center point, and at this point it is hinged. Yes or no? So obviously this block can rotate about this axis. So if I use this is x axis and this is y axis and this is z axis. So this moment of inertia is nothing but it is acting about z axis. Yes or no? So by using parallel axis theorem, perpendicular axis theorem, simply we can write Ia is nothing but this is Ix plus Iy about A. Yes or no? So what about Ixa? So x axis के about अगर मैं moment of inertia लिखूं तो simply can I say this is nothing but this is b into h cube by 12, and similarly moment of inertia about y axis लिखूं तो क्या आएगा ये hb cube by 12. Yes or no? And now if we put these values here, so simply as you know that b is nothing but this is 0.3 into 0.4 whole cube by 12 plus 0.4 into 0.3 whole cube by 12. And if you simplify this, then you will get, this is obviously you know this is the moment of inertia about z axis, correct? So simply here we can get this is equal to 0.0834. After calculation here we get this result 0.0834 meter to the power 4. Yes or no? So from this we can get the momentum. Yes or no? Moment of inertia about A. So now the final momentum is nothing but simply here we can get the final momentum is nothing but this simply here we can get Ia into D, and Ia is nothing but 0.834 0834 into 0.3. Yes or no? Now if I apply conservation of energy, because whenever you try to solve problem related to conservation of momentum, then we also need conservation of energy equation. Yes or no? So when you apply this expression, so simply can I say kinetic energy, initial kinetic energy plus final kinetic energy, the sum of initial kinetic energy plus potential energy is equal to sum of the kinetic energy, final kinetic energy plus final potential energy. Yes or no? This is conservation of energy. So simply can I say, obviously the initial potential energy is 0, it becomes 0, and similarly the final potential energy, the final kinetic energy will be 0. Correct? So simply we can say the initial kinetic energy is nothing but this is half of IA omega square is equal to, what about potential energy? This is mg r minus h by 2. So simply if you put these values, so simply here you will get IA into omega square is equal to, mass is given, that is 1 kg, 9.81 into r is nothing but this is 0.25 minus 2. So from this we get omega is equal to 3.43 radian, because I already know, करेक्ट, I already given है, यहाँ पे हमने already find out कर लिया. तो इसको solve करके आपको क्या मिल जाएगा, ओमेगा. And once you will get omega, so from equation 1, impulse momentum is equal to, obviously this is IA. IA क्या है, 0.0834 into omega square, that is 3.43 square. So from this here we get IF is equal to 0.953 Newton. So this is the answer. Correct? So this is the answer. Okay, so let's see another problem. In this question you can see here, this is question number 3. A rigid block of mass m1 is equal to 10 kg having velocity v0 is equal to 2. So initial mass m1 is given, that is 2 kg, and initial velocity, that is u, or we can say v0, which is also given, that is 2 meter per second. Strikes a stationary block of mass m2 is equal to 30 kg, and obviously its initial velocity is 0. This is u1 is equal to 2 meter per second and u2 is equal to 0 because it is stationary. kg. After traveling 1 meter along a frictionless horizontal surface as shown in the figure, means ये ब्लॉक 1 मीटर ट्रेवल करने के बाद m2 से टकराएगा. द टू मासेस स्टिक टुगेदर, अब दोनों मास स्टिक हो जाएंगे एंड ज्वाइंटली मूव बाय डिस्टेंस ऑफ 0.25 मीटर फर्दर. तो यहाँ पे जो 0.25 साथ में मूव करेंगे along the same frictionless surface before they touch the massless buffer that is connected to the rigid vertical wall by means of a linear spring whose k is already given, the maximum deflection of the spring. So जब ये दोनों मास m1 और m2 मतलब इस पॉइंट पे जब ये कोलाइड करेंगे, यहाँ पे हमारे पास जो टोटल वेट होगा, टोटल मास होगा m1 और m2 होगा, और ये दोनों जब इससे v वेलोसिटी से टकराएंगे तो हाउ मच स्प्रिंग डिफ्लेक्शन टेक्स प्लेस, यस और नो, ये पता करना है. करेक्ट? So let's say if I apply conservation of momentum, principle of conservation of momentum, अगर मैं ये अप्लाई करूं तो कैन आई से m1 u1 प्लस m2 u2, ये तो बिफोर कोलिजन हुआ. आफ्टर कोलिजन दोनों मास क्या हो जा रहे हैं, स्टिक हो जा रहे हैं and they move with velocity v, yes or no. So simply as you see here, m1 is given, that is 2 kg with 2 meter per second velocity, yes or no. So no, sorry, this is 10 kg, not 2 kg, this is 10 kg. Is it clear? So 10 into 2, so simply we can say 10 into 2 plus 30 into u2 is given 0. This is equal to 10 plus 30 into v. So after solving this equation, here we get which is 0.5 मीटर पर सेकेंड. इस वेलोसिटी से दोनों मास मूव करके टकराएंगे किससे, स्प्रिंग सिस्टम से. करेक्ट? तो जब टकराएंगे तो सिंपली इफ आई अप्लाई कंजर्वेशन ऑफ एनर्जी, मीन्स एनर्जी बिफोर कोलिजन इज इक्वल टू एनर्जी आफ्टर कोलिजन. अगर मैं ये अप्लाई कर दूं तो सिंपली कहना इससे ऑब्वियसली m1 प्लस m2 क्यूमुलेटिव मास v वेलोसिटी से मूव कर रहा है, जो टकराएगा दैट इज काइनेटिक एनर्जी. which will be converted into spring energy, yes or no, strain energy, that is half of kx square. So if you simplify this, then you will get x, and x is nothing but, simplify, right, x is nothing but this is m1 plus m2 into v over k square root. So if I put these values, so simply can I say this is 10 plus 30 into 0.5, or obviously this is square, 0.5 square over k, that is 10 to the power 5 already given है question में. So after simplifying this, this will gives us 0.1 meter, correct? Sorry, 1 by 100 meter, or simply you can say this is equal to 10 centimeter. So this is the answer. You just simplify. I already simplified this, correct? So like this you will get the answer, yes or no. So I hope you will understand how to solve this question. This is very simple question. And now let's see another problem. You can see here, this is question number 4. This is question number 4. The mass 2 kg, sorry, the 2 kg block as shown in the figure, this is a block, rests on a smooth horizontal surface and is attached to a massless elastic cord. This is the elastic cord that has stiffness 5 Newton per meter. The cord hinged at O is initially unstretched and the always remain elastic. The block is given velocity v of 1.5 meter per second in the horizontal direction perpendicular to the cord. The magnitude of the velocity in the meter per second of the block at the instant the cord is stretched by 0.4 meter. Is that clear? So simply here we need to apply conservation of energy only, yes or no? So you can see given that, first you write क्या question में दिया हुआ है. So given that mass is given, that is 2 kg. Is that clear? Velocity is also given, that is 1.5 meter per second. And stiffness is given, that is k is equal to 5 Newton per meter. So now if I apply the conservation of energy principle, so simply can I say this is nothing but this is half mv square is equal to half kx square, yes or no? So from this simply if I write 2 into 1.5 square is equal to k, which is already given here, that is 5 into x square, yes or no? So from this you will get x. And one more thing, this is the stiffness, and obviously here we have one more component, that is mv naught square. When this when this cord is stretched, then obviously we have some final velocity of this block, yes or no? So simply can I say this is half of m, that is 2 into v naught square, yes or no? And one more thing, x is given here in this problem, yes or no? How much? That is 0.4 meter. This is 0.4 meter whole square. So after this, if you simplify this expression, then you will get v naught is nothing but this is equal to 1.36 meter per second square. And is it clear? So obviously you see this is initial momentum and this is initial energy, and this is final energy. And obviously when you stress this string, then obviously it gains some kinetic energy along with strain energy, yes or no? So this is strain energy due to stretching, and this is kinetic energy because of this velocity, yes or no? Okay, so let's see another problem. So this is question number 5th. Is it clear? You can see in this question we have a mass or a ball of mass 3 kg moving with a velocity 4 meter per second. So let's say m1 is given here, that is 3 kg, and its velocity, initial velocity is also already given here, that is u1 is equal to 4 meter per second, undergoes perfect elastic direct central impact. Means अगर ये elastic collision है तो obviously here we get E is equal to 1, और किससे टकरा रहा है? विथ स्टेशनरी बॉल ऑफ मास m. तो m2 इज नथिंग बट दिस इज m और u2 जो होगा वो 0 क्योंकि ये स्टेशनरी है. आफ्टर द इम्पैक्ट इज ओवर द काइनेटिक एनर्जी ऑफ द 3 kg बॉल इज. तो 3 kg बॉल की एनर्जी क्या होगी? तो काइनेटिक एनर्जी ऑफ 3 kg बॉल is nothing but this is 6 joule. The possible value of m. So we need to find out what is the value of m. Is it clear? So simply if you see, if I apply a conservation of energy principle, sorry, conservation of momentum first, because we need to find out velocity after collision, conservation of momentum. If we can apply this, then can I say it is nothing but this is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Yes or no? So you can see here we have 3 kg and velocity is given, that is 4, and u2 is given. So let's say this is m into 0. This is equal to 3 kg into v1 velocity I don't know plus m into v2. Yes or no? So simply from this expression, simply here we get 3v1 plus mv2 is equal to 12, and this, let's say this is equation 1. So now, as you know, the kinetic energy of 3 kg ball. So kinetic energy of 3 kg ball is nothing but this is half m1 v1 square. Yes or no? Half m1 v1 square, and which is already given here 6. So can I say v1 is nothing but this is 6 into 12 over mass, and mass is nothing but 3 square root. So after simplifying this, you will get 2 meter per second. So v1 is nothing but this is 2 meter per second. यहाँ से हमें v1 मिल जाएगा. So now if we can apply v1 is equal to, or yes, one more thing, yes, I forget to write here. If you simplify this expression, then v1 is nothing but this is 6 into 2. v1 square is equal to 6 into 2 over m1, and m1 is already given here, which is equal to 3 kg. Yes or no? So v1 is nothing but, here we need to apply square root. So can I write this is plus minus 6 into 2 by 3. So after simplifying this, you will get plus minus 2 meter per second. ये पॉजिटिव भी हो सकता है और नेगेटिव हो सकता है, वी डोंट नो. इज इट क्लियर? सो नाउ now as you see here, this collision is perfect elastic. Yes or no? This collision is perfect elastic. So can I apply this relation? For perfect elastic collision, this is E1 is equal to 1. So simply we can say this is V2 minus V1 over U1 minus U2. Yes or no? So simply we can say V2 minus V1 is equal to, U2 is 0 and U1 is nothing but this is, U1 is nothing but this is how much? So let's see, U1 is, yes, 4 meter per second. U1 is 4 meter per second. Yes or no? So can I say this? And U2 is obviously, U2 is 0. Yes or no? U2 तो यहाँ पे 0 है. So this is equation 2. So can I say from equation 2, अगर मैं V1 की पॉजिटिव वैल्यू पुट करूं, let's say V1 is equal to 2 meter per second. So simply we can say V2 is equal to 6 meter per second. And similarly, if V1 is equal to minus 2 meter per second, then what about V2? If you put this, V1 is equal to minus 2. So V2 is nothing but this is 2 meter per second. Yes or no? And once you get V1 and V2 both, so here we have two combinations. So from equation 1 क्या कह रहा है? 3v1 plus mv2 is equal to 12. So for first case, if I say for first case, when v1 is equal to plus 2, तो V2 इज इक्वल टू क्या है 6 है। इस केस में m क्या आएगा, इफ यू पुट दिस वैल्यू देन सिंपली यू सी आई एम डायरेक्टली राइटिंग 3 into 2 plus m into V2 is equal to 12. तो 3 into 2 6 और 12 में 6 by 6 that is 1. तो यहाँ से आंसर मिलेगा 1 kg. And similarly if V1 is equal to -2 then V2 becomes 2. Yes or no? और इस केस में जब मैं मास कैलकुलेट करूंगा then what you will get, you see here again you put this these values on this expression. So V1 is nothing but this -2, तो 3 into -2 that is -6 और इधर आके ऐड हो जाएगा तो ये 18 हो जाएगा और V2 हमारे पास 2 है तो सिंपली कैन आई से दिस इज नथिंग बट दिस इज 9 kg. यस और नो? तो आंसर क्या होगा यहाँ पे, इधर 1 kg और 9 kg. यस और नो? या तो मास की जो वैल्यू होगी या तो 1 kg होगा या फिर 9 kg. यस और नो? 1 kg और 9 kg. So let's see which one is the right choice. Yes, so option B is the right one. Yes or no? So like this you can solve this problem. This is again very simple question. Yes or no? Okay, so now let's see another question. Okay, so you can see here in this question a block P of mass 2 kg. This is a block whose mass is 2 kg slides down the surface and has a speed of 20 meter per second at the lowest point. Means at this point its velocity is nothing but this is 20 meter per second. Yes or no? At where the local radius of curvature is 2 meter as shown in the figure, assuming g is 10 meter per second square, the normal force. So we need to calculate normal force. Yes or no? Normal force. So simply if I say, if I draw its a free body diagram, then it is looking like this. Correct? So here we have a block. Here we have a block whose velocity is v like this, and its weight is acting in the downward direction, that is mg. और यहाँ पे एक नॉर्मल रिएक्शन आएगा that is n. Yes or no? So from Newton's second law, if I say from Newton's second law, can I say normal reaction minus mg is equal to force F, that is mass into acceleration. Yes or no? Mass into acceleration. And obviously this mass is moving in the angular path, so here we have angular acceleration. Yes or no? So it can be written as mass into v square by r. Is that clear? So n is nothing but, from this n is nothing but, can I say mg plus mv square by r. Yes or no? So what about velocity? So velocity, can I say this is nothing but this is root 2 gh. Yes or no? And 2g is given, that is 10. And what about height? Height is 20 meter. Yes, this mass is placed at a height of 20 meter. Yes or no? This height is 20 meter. Yes or no? So simply from this, this is 400. So can I say this is 20 meter per second velocity? So n is equal to 2 into 10 plus 2 into 20 स्क्वायर, और किस रेडियस से, द रेडियस ऑफ कर्वेचर क्या है यहाँ पे 2 मीटर. Yes or no? So after simplifying this you will get 420 Newton. 420 Newton. This is the answer. Very simple question. Yes or no? Okay, so let's see. This is question number 5 and this is question number 6. So simply here I put question number 6 and this is question number 7. This is question number 7. Is it clear? So in this question you can see here two discs A and B with identical mass m and radius r are initially at rest. They roll down from the top of identical inclined plane. So here we have inclined plane like this. This is inclined plane 1 and obviously here we have a disk, correct, and this is system 1 and similarly this is system 2, correct. ये हमारा क्या है, this is a disk A and this is disk B, both are rolling on this inclined surface, yes or no. They roll down from the top of the identical inclined planes without slipping. There is no slipping. Disk A has of its mass concentrated at the rim. ये क्या है, this is rim. तो इसको मैं ऐसे बना देता हूँ, this is rim. Correct? इसका सारा mass rim में concentrated है. Obviously, if I write its moment of inertia, then what you will get? This is nothing but this. Its moment of inertia is nothing but this is mr square. And disk B has the mass uniformly distributed. Whenever you have distributed moment mass, then you will get distributed moment of inertia. So its average moment of inertia is nothing but this is mr square by 2. Yes or no? At the bottom of the plane, the ratio of the velocity of the center of a disk A to the velocity of center of disk B. So VA over BB about center you need to calculate. इस ratio को पता करना है. Is it clear? So simply you can say at this position it has a potential energy, and when this disk can roll out from top position to bottom, that the entire potential energy will be converted into kinetic energy. So simply can I say, if I apply conservation of energy, so from this loss in kinetic energy can we say this is equal to gain in potential, loss in potential energy, not kinetic energy. Loss in potential energy is equal to, can I say this is gain in kinetic energy. जो पोटेंशियल एनर्जी में लॉस हो रहा है वो सारा पोटेंशियल काइनेटिक एनर्जी में गेन हो जाएगा. तो लॉस इन पोटेंशियल एनर्जी, तो पोटेंशियल एनर्जी थी कितनी, mg है. अब गेन कितना होगा, सो कैन आई से हाफ ऑफ mva स्क्वायर प्लस हाफ ऑफ ia ओमेगा स्क्वायर. ये सारा इसमें काइनेटिक एनर्जी क्या होगा, काइनेटिक एनर्जी देखो, दिस बॉल कैन रोटेट अबाउट इट्स ओन सेंटर, अपने सेंटर के अबाउट रोल हो रहा है, साथ में इट हैज सम टेंजेंशियल वेलोसिटी. तो इसकी हमारे पास एंगुलर काइनेटिक एनर्जी और लीनियर काइनेटिक एनर्जी दोनों होगा, दोनों का सम हमने यहाँ पे लिख दिया. ये सानो. और दूसरी बॉल के लिए अगर हम लिखें तो कैन आई से ये हमारे लिए किसके लिए हुआ, फॉर ए, एंड सिमिलरली फॉर बॉल बी अगर लिखें तो ऑब्वियसली मास तो दोनों का सेम है, बस यहाँ पे हुआ है क्या कि मास डिस्ट्रीब्यूटेड है, इसकी वजह से इनकी काइनेटिक एनर्जी डिफरेंट होगी. बाकी पोटेंशियल एनर्जी तो सेम, यस मास इज आल्सो सेम बट डिस्ट्रीब्यूशन डिफरेंट है, करेक्ट है. तो दोनों की पोटेंशियल एनर्जी तो सेम होगी लेकिन काइनेटिक एनर्जी आपको डिफरेंट मिलेगी. तो इन दोनों इक्वेशंस को अगर हम इक्वेट कर दें, सो कैन आई से फ्रॉम इक्वेशन 1 एंड 2, अगर मैं इन दोनों इक्वेशंस को इक्वेट कर दूं तो कैन आई से इसको हम इस तरीके से लिख सकते हैं क्या, हाफ ऑफ mva स्क्वायर प्लस हाफ ऑफ ia इंटू ओमेगा ए स्क्वायर इज इक्वल टू हाफ ऑफ mvb स्क्वायर प्लस हाफ ऑफ ib इंटू ओमेगा b स्क्वायर. yes or no? So can I say this half is cancelled out with this half, yes or no? और इंस्टेड ऑफ ओमेगा ए को हम क्या लिख सकते हैं, दिस इज नथिंग बट v इज इक्वल टू आर ओमेगा. तो ओमेगा ए इज इक्वल टू वी ए बाई आर, ये सर नो. और रेडियस तो दोनों के लिए सेम है, वी वी आई बाई आर, ये सर नो. इनको रिप्लेस कर दें एंड ऑब्वियसली मास इज ऑल्सो सॉरी. तो सिंपली करें से m टाइम्स ऑफ वी ए स्क्वायर प्लस ओमेगा आई ए को क्या लिख सकते हैं हम, एम आर स्क्वायर इंटू ओमेगा क्या लिख सकते हैं, वी ए स्क्वायर बाई आर स्क्वायर. ये सानो क्योंकि ओमेगा इक्वल टू क्या रहेगा, वी बाई आर, वी ए स्क्वायर बाई आर स्क्वायर. सिमिलरली इसको हम क्या लिख सकते हैं, एम इंटू वी बी स्क्वायर प्लस आई बी को क्या लिख सकते हैं, एम आर स्क्वायर बाई 2 इंटू इसको हम क्या लिख सकते हैं, वी बी स्क्वायर बाई आर स्क्वायर. ये सानो. So you can see this r is cancelled out with this r is cancelled out with this. So simply here we can get 2 times of mva square. This is equal to, अगर मैं इसको सिंप्लीफाई करूं तो क्या मैं ऐसे लिख सकता हूँ 3/2 टाइम्स ऑफ एम वी बी स्क्वायर. तो वी नीड टू राइट वी ए स्क्वायर ओवर वी बी स्क्वायर. तो क्या रिजल्ट आएगा दोस्तों, मास इज ऑब्वियसली कैंसिल आउट. So simply here we can get 3/4, or if I say VA by VB, so can I write this is square root of 3/4? Square root of 3/4, yes or no? तो सिंपल से प्रिंसिपल अप्लाई करना था, that is conservation of energy. So from this option, if I say option A is the right choice, yes or no? Correct. Okay, so let's see another question, that is question number 8. Question number 8, is it clear? Question number 8. So you can see here in this question, a particle of unit mass m is moving on a plane. Its trajectory is polar coordinates is given. This ये जो trajectory है particle की वो polar coordinate का form दिया हुआ, that is r function of t is equal to t square and theta is a function of t is equal to t. Where t is the time, then the kinetic energy of the particle at t is equal to 2 seconds. तो हमें क्या करना है, पार्टिकल की काइनेटिक एनर्जी पता करनी है. So let's say mass of the particle is given, that is unit mass. So let's I consider that is 1 kg, and r is given, that is t square, yes or no, and theta is given is t. Correct. R is a function of t, so simply I am writing r is equal to t square, theta is equal to t, yes or no. So the kinetic energy of this particle is nothing but this is half mv square, yes or no. एंड यही हमें पता करना है कि इसकी वैल्यू क्या होगी एट t इज इक्वल टू 2 सेकेंड. 2 सेकेंड में इसकी काइनेटिक एनर्जी क्या होगी. तो वी नीड टू फाइंड आउट इट्स वेलोसिटी वेक्टर. तो वेलोसिटी वेक्टर, ऑब्वियसली दिस वेलोसिटी इज गिवन इन द पोलर कोऑर्डिनेट. तो पोलर कोऑर्डिनेट में क्या होता है, दिस इज r ओमेगा t यूनिट वेक्टर प्लस dr/dt r यूनिट वेक्टर, yes or no. इस फॉर्म में लिखा दिया जाता है. And you can see here r is given that is t square. So can I say this is omega t square, and what about r? A particle of unit mass is moving on a plane. Its trajectory is polar coordinate t is this, and where t is time, the kinetic energy of the particle t is equal to 2 seconds. Yes. So from this, can I say r is equal to t square? So simply if I write a dr by dt, this is nothing but this is omega and this is equal to 2t, yes or no. And t is given, that is 2 seconds. So can I say omega is equal to 4 radian per second, yes or no. So from this, if I write vector v is equal to r is nothing but this is t square into omega, plus here we have dr by dt into r. So dr by dt is nothing but this is 2t. dr by dt, simply I am writing dr by dt is nothing but this is 2t into r vector, and yes, I forgot to write here t vector. So this is t unit cap, yes or no. And yes, one more thing, omega is nothing but d theta by dt, yes or no. Omega is nothing but this is d theta by dt, yes or no. And theta is given, if theta is equal to t, can I say d theta by dt which is equal to 1 and which is equal to omega, और ये क्या होगा 1 रेडियन पर सेकेंड, करेक्ट. So v vector is nothing but t square into 1 into t cap plus 2t into r cap, yes or no. अब अगर मैं वेलोसिटी देखूं एट t is equal to 2 सेकेंड, तो कैन आई से दिस इज 4 t cap plus 2 r cap. तो इसका मैग्नीट्यूड क्या होगा v वेलोसिटी वेक्टर का. So this is nothing but this is square root of 4 square plus 2 square. So 16 और 8 4 20, square root of 20. यस आर नो। तो यहाँ से हमें मिल गया वेलोसिटी। So now if I write kinetic energy, so can I say this is nothing but this is half of mv square. Half mass is, let's say, unit mass, and velocity is square root of 20. So this is kinetic energy is nothing but this is 10. Oh yes, I make a mistake. Let's say this is 2t, correct? So if here we need to find out velocity at t is equal to 2 seconds. So 2 into 2, that is 4, correct? So this is 4, not 2 square, 4 square. So let's say this is square root of 32. 4, 16 plus 16 is square root of 32. Now it is correct. Square root of 32. Yes or no? So simply can I say, and this is whole square. So 32 over 2. So the kinetic energy is nothing but this 16. Kinetic energy is nothing but this is 16. Yes or no? And obviously this is in joule. So option C is the right option. Okay. Okay. So let's see another problem. That is question number 9. This is question number 9. Question number 9. So a system of particles in motion has a mass center G as shown in the figure. The particle I has a mass of mi and its position with respect to a fixed point O is given by the position vector Ri. The position of the particle with respect to G is given by the vector Pi. The position of the particle respect to G, this is a position vector. The time rate of change of its angular momentum of the system of the particle about G we need to determine, correct? So this is the particle whose position vector is Pi and its mass is m, and obviously this particle is positioned from O is lie on at a distance of r. So initially it is lie here, and after that, after rotation, it will move from here to here, or it will move about the radius r. Yes or no? So simply can I write rate of change of angular momentum, rate of change of angular momentum is nothing but, let's say this is L dot, or simply we can say dl by dt, where L is a angular momentum, where L is a angular momentum. Angular momentum is always represented by L, and this is nothing but this is rho times of P, correct? So simply if I write in the vector form Lig about G is nothing but this is rho I and Pi, correct, for a particle, and this is the angular momentum for a particle, एक पार्टिकल के लिए whose mass is m, और किसके रिस्पेक्ट में अबाउट g. यस आर नो? ये किसका एंगुलर मोमेंटम है? एक पार्टिकल का जिसका मास कैपिटल m है, और सिंपली यू कैन से mi. वाई आई एम राइटिंग कैपिटल m? दिस इज mi. एक पार्टिकल है जिसका मास mi है और उसका एंगुलर मोमेंटम अबाउट g अगर मैं लिखूं तो इसे मैं लिख सकता हूं rho I into pi. Yes or no? So now you can see in this where Pi is nothing but this is linear momentum, which is equal to mi into vi dot vi. Yes or no? Mi into vi. This is called as linear momentum of particle. A particle, linear momentum of a particle, linear momentum of a particle whose mass is mi. Yes or no? जिसका मास क्या हो? जिसका whose mass is mi. जिसका मास क्या है? mi. Is it clear? So this is a linear momentum. So angular momentum is nothing but this is rho I into linear momentum, that is rho I into mi into vi. Yes or no? ऐसे लिख सकते हैं. And instead of velocity vector, it can also be written like this. This is ri dot. Ri dot. Yes or no? Obviously, you know that this is nothing but this is dr by dt, and it can also be written as r dot. Yes or no? So this is linear momentum about g. Obviously, this is linear momentum. Angular momentum about g. Is that clear? So simply can I write angular momentum of a body? ये तो एक पार्टिकल के लिए हो, तो बॉडी के लिए क्या होगा? समेशन ऑफ रो आई एम आई इंटू आर आई डॉट. ये था नो. तो अगर मैं ऐसे ही सारे पार्टिकल का एंगुलर मोमेंटम पता करूं और उनका सम लिख दूं, तो कैन आई से दिस इज द टोटल एंगुलर मोमेंटम ऑफ द बॉडी. ये था नो. तो सिंपल सा ये एक पार्टिकल का एंगुलर मोमेंटम है, और अगर मैं ऐसे सभी पार्टिकल का एंगुलर मोमेंटम पुट कर दूं, और लेट्स से दिस इज आई इज इक्वल टू 1 to n, then you will get the angular momentum of whole body. Is it clear? Okay, so let's see, this is another question, that is question number 10. And again, this is very simple question. So a circular disc of radius 100 mm. Yes, this is a disc whose radius is 100 mm. 100 mm, yes or no? And mass of 1 kg, its mass is 1 kg. Initially at rest means its initial velocity is initially is rest at a position A, rolls without slipping down curved path as shown in the figure. So v of the speed v of the disk when it reaches to point B is, जब ये पार्टिकल यहाँ पहुंचता है तब इसकी वेलोसिटी क्या होगी. तो अगेन जब भी आपको इस तरीके के केस मिले, सो सिंपली यू अप्लाई कंजर्वेशन ऑफ एनर्जी. कंजर्वेशन ऑफ एनर्जी, क्योंकि जब किसी एक हाइट में कोई पार्टिकल लाई कर रहा है, देन ऑब्वियसली इट हैज सम पोटेंशियल एनर्जी, एंड इफ आई से लॉस इन पोटेंशियल एनर्जी is nothing but this is gain in kinetic energy. Yes or no? So what about loss in potential energy? So can I say this is mgh? And what about loss in kinetic energy? And obviously this here we have a disk which has some linear velocity, and along with this is also rotating with some omega speed. So can I say this is I omega square plus half of mv square? Yes or no? So simply we can say mgh is equal to, and yes you can say this is a circular disk, and disk का मोमेंट ऑफ इनर्शिया क्या होता है? mr स्क्वायर बाई 2. और आप याद कैसे रखोगे? देखो रिंग जब रहता है तो होल मास क्या होता है? आउटर पेरिफेरी में कंसंट्रेटेड होता है, इसलिए इस रिंग का मोमेंट ऑफ इनर्शिया हमेशा क्या होगा? mr स्क्वायर. करेक्ट. इसका मोमेंट ऑफ इनर्शिया हमेशा हम कंसिडर करेंगे mr स्क्वायर. लेकिन वहीं पे अगर मैं डिस्क की बात करूं तो यहाँ पे जो मास होता है वो डिस्ट्रीब्यूटिव नेचर का होता है. तो आप सिंपल से याद रखो कि आपको इसका मोमेंट ऑफ इनर्शिया क्या निकालना है? एवरेज मोमेंट ऑफ इनर्शिया. तो एवरेज को क्या होगा? इससे आप 2 से डिवाइड कर दो. तो इस तरीके से आप इसको याद रख सकते हो. और v की जगह क्या लिख सकता हूँ? v स्क्वायर बाई आर स्क्वायर. यस आर नो? प्लस हाफ ऑफ एम वी स्क्वायर. यस आर नो? इज इट क्लियर? सो दिस इज कैंसल आउट विद दिस, and mass is also cancel out from both the sections. So simply here we get h gh is equal to, और 2 से मल्टीप्लाई कर दो, 2 gh is equal to, and yes here we have one more 2. So can I say this is v square by 2 plus v square, or simply we can say 3v square by 2. So v square is nothing but simply here we get 4gh by 3. So v is nothing but simply here we can get square root of 4, and g, yes g is given that is 10, h is also given that is 30 meter over 3. So now if you simplify this, then here you will get 20 meter per second. ये आपको square root of 400 देगा, और इसका स्क्वायर रूट हटाएंगे तो हमें क्या मिल जाएगा? 20 मीटर पर सेकेंड. So this is the answer. Correct? So whenever you have this kind of things, so you must use conservation of energy principle, and don't forget to write this component also in kinetic energy, because this disk is rotating about its own axis as well as it has some linear velocity. So because of its own velocity, own angular speed, it has some angular kinetic energy, and it also has some linear velocity. That's why it has some linear velocity also. Is it clear? Okay, so next you can see the previous one, that is question number 10. This is question number 11. A point mass having mass capital M is moving with a velocity v at an angle theta. So you can see this is a mass. This is a particle whose mass is m, which is moving in the velocity v along this theta angle, and obviously after some time it collide with this surface somewhere here, and after collision it will reflect to here. Yes or no? So can I say after reflection it has two velocity component, one is horizontal, another is vertical, and initially it also has some its horizontal component and its vertical component. This is v cos theta and this is v sin theta, and let's say after collision it has velocity m is moving with velocity v at an angle theta to a wall as shown in the figure. The mass undergoes a perfect elastic collision. You can see this is perfect elastic collision, means if you have perfect elastic collision, so can I say for this E is equal to 1. So velocity velocity of separation over initial velocity ये same होगा. So v is equal to u. Yes or no? v is equal to u. Is it clear? और यहाँ पे क्या होगा, और u क्या है, u is already given here, so this is v. So can I say this velocity is also v? Yes or no? This velocity is also here, we have v, and obviously if, this is perpendicular to this. So if I say, if I draw perpendicular from it, then this is theta, then this is 90 minus theta, then this is theta. If this is theta, then we can say this is theta, and if this is theta, so simply you can say ये एंगल आपका थीटा है, तो ये क्या आ जाएगा, दिस इज v sin theta and this is v cos theta. Yes or no? So we can say, if you can say this is pi is the initial linear momentum, initial linear momentum. So can I say this is nothing but this is m v cos theta I plus m v sin theta j. Yes or no? ये हमने वेक्टर फॉर्म में रिप्रेजेंट किया, इसलिए हमने इस तरीके से लिखा. सिमिलरली इफ आई राइट पी एफ इज अ फाइनल मोमेंटम, फाइनल लीनियर मोमेंटम. यस और नो? So can I say this is nothing but this is m v cos theta I minus m v sin theta j. Yes or no? So change in linear momentum delta p is nothing but this is p final minus p initial. So can I say this is nothing but this is mv cos theta I minus mv sin theta j minus mv cos theta I minus mv sin theta j. Yes or no? So this is cancelled out with this. So delta p is nothing but this is minus or 2 times of mv, sorry, sin theta not cos theta, sin theta j. तो सिर्फ ये आपसे यहाँ पे वेक्टर का कॉन्सेप्ट पूछ रहा है, बाकी यहाँ पे कुछ और नहीं है. इज इट क्लियर? और ये क्या है, दिस इज जी जे. इज इट क्लियर? So from this yes, option D is the right one. Okay, so this is correct answer. So this is the key point. When you apply perfect collision, then obviously initial and final velocities remain same. So you just write its component and then write its initial and final momentum, and then you write that is change in linear momentum. Yes or no? Okay, so let's see another question. So this is question number 12. A mass of 2000 kg is currently being lowered at a velocity of 2 meter per second. ये जो मास है 2 kg का, सॉरी 2000 kg का, जो कि 2 मीटर पर सेकेंड से डाउन हो रहा है फ्रॉम द ड्रम एज शोन इन द फिगर. द मास मूवमेंट ऑफ इनर्शिया ऑफ ड्रम, इसका मास मूवमेंट ऑफ इनर्शिया ड्रम का दिया हुआ है, दैट इज 150 kg मीटर स्क्वायर. on applying the brake, the mass is brought to rest at a distance of 0.5 meter. The energy absorbed by the brake. तो सिंपली हमें क्या निकालना है? You can see here energy, initial energy plus the energy consumed for braking, that is brake energy. ये आपका क्या होगा? This is final energy. Again here we apply conservation of energy. Yes or no? तो initial energy क्या होगा? Half of I omega square plus half of mv square. Yes or no? And let us say this is v1. Is it clear? Plus its potential energy, that is mgh1. ये तो हो गया आपका क्या है? This is initial energy. Yes or no? This is its initial energy. करेक्ट. मतलब हमने यहाँ पे क्या लिखा? पोटेंशियल एनर्जी प्लस काइनेटिक एनर्जी. टोटल एनर्जी यही आपका इनिशियल एनर्जी कहलाएगा जब ये मूव नहीं कर रहा था. यस और नो? जब ये मास सिस्टम मूव नहीं कर रहा था, सॉरी, जब ये जस्ट मूव करने स्टार्ट किया, देन इट हैज दिस एनर्जी. एंड इफ आई से इट्स अ फाइनल एनर्जी, तो सिंपली कैन आई राइट दिस इज हाफ ऑफ आई तो चेंज होने से रहा. यस और नो? एंड ऑब्वियसली दिस इज 1, तो ओमेगा 2 स्क्वायर प्लस हाफ एम वी टू स्क्वायर प्लस, और यहाँ पे पोटेंशियल एनर्जी क्या हो जाएगा? एम जी एच टू. तो वी नीड टू फाइंड आउट ई ब्रेक. ब्रेकिंग के लिए कितना एनर्जी कंज्यूम हुआ? तो सिंपली कहने से दिस इज फाइनल माइनस इनिशियल. ये सर नो? तो अगर मैं इसका डिफरेंस लिखूं तो मैं ऐसे लिख सकता हूँ हाफ ऑफ आई ओमेगा 2 स्क्वायर माइनस ओमेगा 1 स्क्वायर प्लस हाफ ऑफ एम वी टू स्क्वायर माइनस वी वन स्क्वायर प्लस एम जी एच टू माइनस एच वन. Yes or no? So you can see here the mass moment of inertia is given here already, that is 150. And what about omega 2 minus omega 1? So obviously at a final condition this block is going to be rest. Yes or no? तो यहाँ पे रोटेशन क्या हो जाएगा? 0. Yes or no? So omega 2 minus omega 1 स्क्वायर अगर मैं देखूँ यहाँ पे, एंड ऑब्वियसली दिस ये जहाँ पे जो ब्रेकिंग एनर्जी होगा वो नेगेटिव होगा. And what about, yes, velocity is 2 meter per second and this height is also given here. So v is equal to r omega लिख सकता हूँ. तो omega is equal to v by r. Yes or no? So omega is equal to v given है, that is 2 by 2, that is 1 radian per second. तो यहाँ पे क्या आ जाएगा दोस्तों? तो ऑब्वियसली ओमेगा 2 तो 0 हो जाएगा. ओमेगा 1 हमारे पास हो जाएगा माइनस 1 स्क्वायर प्लस हाफ ऑफ मास इज गिवन 2000. फाइनल वेलोसिटी भी 0 हो जाएगी, तो इनिशियल वेलोसिटी माइनस 2000 स्क्वायर. ये सर नो? ओहो, दिस वेलोसिटी इज 2 not 2000. And you know why I am writing negative sign? Because this is final velocity, सॉरी इनिशियल वेलोसिटी, और यहाँ पे माइनस है, और ये हमारे पास क्या होगा? दिस इज 0 एंड दिस इज 0 एंड प्लस m जो है 2000 इंटू जी क्या है यहाँ पे? दैट इज 10. लेट अस टेक, और h2 माइनस h1 क्या होगा दोस्तों? कितना चेंज होगा? लेट्स यहाँ पे डिस्टेंस दिया होगा, दैट इज 0.5 मीटर. यस और नो? तो कहाँ पे रेस्ट होगा ये? 0.5 मीटर. सो लेट अस टेक दिस इज माइनस, ये भी आपके पास क्या होगा? विथ माइनस साइन माइनस h1 इज, लेट्स टेक h1 इज 0, सॉरी h2 इज अ रेफरेंस, सो h1 यहाँ पे माइनस आ जाएगा क्या? 0.5 मीटर. तो जब आप इसको सिंप्लीफाई करोगे तो आफ्टर सिंप्लीफिकेशन यू विल गेट माइनस 14.11 किलो जूल. एंड नेगेटिव साइन क्या क्यों आ रहा है? बिकॉज ये जो एनर्जी है ये ब्रेकिंग के लिए इस्तेमाल होगी. नेगेटिव एनर्जी का मतलब क्या हुआ? नेगेटिव साइन का यहाँ पे कोई लेना देना नहीं है. इज इट क्लियर? या सिंपली आप यहाँ पे अगर मैं साइन कन्वेंशन फॉलो करूँ तो यहाँ पे आप पॉजिटिव साइन ले सकते हो. नीड नॉट टू वरी अबाउट दिस. करेक्ट? क्योंकि एनर्जी नेगेटिव नहीं होती कुछ. ठीक है? नेगेटिव साइन सिर्फ डायरेक्शन बता रहा है कि ये जो एनर्जी है ये ब्रेकिंग के लिए यूटिलाइज हो रही है. इज इट क्लियर? हेलो? So simply we can get this result. So 14.11 kilojoule is the correct answer. Okay, so let's see another problem. This is a question number 13. A point mass m is released from rest and slide down a spherical ball. एक मास है जो कि यहाँ पे रेस्ट पे है and then starts sliding with a radius r of height h as shown in the figure. The surface of the ball is smooth, no friction. The velocity of the mass at the bottom of the ball. यहाँ पे हमें इसकी velocity निकालनी है. Is it clear? At the bottom में हमें क्या निकालना है? यहाँ पे velocity निकालना है. Is it clear? So again ये प्रॉब्लम हम ऑलरेडी कर चुके हैं. अगेन इफ आई अप्लाई लॉस इन पोटेंशियल एनर्जी इज इक्वल टू गेन इन काइनेटिक एनर्जी, डायरेक्टली अप्लाई कर दें तो यहाँ पे पोटेंशियल एनर्जी क्या होगा, दैट इज mgh. काइनेटिक एनर्जी क्या होगा, यस. तो यहाँ पे देखो ये फ्लैट सरफेस है बंधो. ये आपके पास क्या है, एक मास है, पॉइंट मास है जो कि रेक्टेंगुलर होती है. ये रोटेट नहीं हो रहा तो इसका कोई एंगुलर काइनेटिक एनर्जी नहीं हुआ. So simply we can write mv square. So m is cancelled out with this m. So v is nothing but this is root 2 gh. So this is very simple question. Yes or no? So root 2 gh is the correct answer. Root 2 gh is the correct answer. Okay, so let's say this is question number 14. A ball of mass 0.1 kg initially at rest dropped from height 1 meter. The ball hits the ground and bounce off the ground. Yes or no? एक मास है, करेक्ट है, जो कि सपोज यहाँ पे है और ये ग्राउंड है लेट्स से एक, और इसका मास क्या है, दिस इज 0.1 kg. इनिशियली एट रेस्ट, यहाँ पे रेस्ट पे है एंड इट्स ड्रॉप फ्रॉम हाइट ऑफ 1 मीटर. सो ये सेंटर हाइट अगर मैं देखूँ तो दिस इज 1 मीटर. यहाँ से ड्रॉप किया तो ऑब्वियसली यहाँ से जब ये वेलोसिटी इससे टकराएगा देन इन दिस केस इट्स वेलोसिटी लेट्स से v1, तो क्या आ जाएगा, रूट स्क्वायर रूट ऑफ रूट 2 gh. ये सार नो यहाँ पे इसकी वेलोसिटी क्या होगी, रूट 2 gh. तो दिस इज नथिंग बट इफ आई टेक g is 10 and h is 1 meter, so simply here we get root 20 meter per second. इस वेलोसिटी से यहाँ पे ये टकराने वाला है. ये सार नो. And after collision, the ball hits the ground and bounce back. Upon impact with the ground, the velocity reduced to 20%. तो जो v2 होगा, ये तो हमारे पास क्या होगा, दिस इज v1. v2 जो होगा वो 0.8 टाइम्स ऑफ v1 है. ये सार नो. सो 0.8 टाइम्स v1 दैट इज स्क्वायर रूट ऑफ 20. द हाइट ऑफ द बॉल, मतलब ये टकराने के बाद यहाँ पे पहुंच जाएगा, तो ये हाइट क्या होगी. So let's say this height is h. So can I say velocity when it reaches to this point is nothing but this is root 2 gh. This is equal to 0.8 into root 20. So h is nothing but this is 0.8 square into 20 over 2 into 10. So this is cancelled out. So h is nothing but this is 0.64 meter. H is nothing but this is 0.6 meter. So this is the answer. So I hope you will understand how we will get this answer. Yes or no? Correct? Okay, so let's see another question. That is question number 15. So in this question you can see here a small ball of mass 1 kg is moving with a velocity of 12 meter per second. Correct? So let's say a small ball of mass, let's say m1 is equal to 1 kg moving with a velocity u1 is equal to 12 meter per second, undergoes direct central impact with a stationary ball whose mass is 2 kg and obviously it is stationary, so its initial velocity is 0. The impact is perfect elastic, means E is equal to 1. So the speed in meter per second of 2 kg mass ball. So we need to find out v2. Yes or no? So if I use E is nothing but, as you know, that v2 minus v1 upon u1 minus u2. This is the ratio of velocity of separation to the velocity of approach. Yes or no? So if I use this relation, so can I say u1 minus u2 is equal to v2 minus v1? So from this v2 minus v1 is equal to u1 is already given here, that is 12 meter per second, and u2 0. So this is equation 1. Now apply conservation of momentum, correct? Conservation of momentum principle. So simply can I say this is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So simply m is 1 kg into v1 I don't know, plus m2 is 2 kg, v2 is also not given. This is equal to m1, that is 1 into 12 plus 2 into 0. So simply here we can get v1 plus 2v2, v1 plus 2v2, this is equal to 12. This is equation 2. So can I say from इक्वेशन 1 एंड इक्वेशन 2, इन दोनों इक्वेशन को सॉल्व करो तो मैं डायरेक्ट यहाँ पे रिजल्ट लिख देता हूँ. तो आफ्टर सॉल्विंग दिस हियर वी गेट v1 इज इक्वल टू -4 मीटर पर सेकेंड and v2 is nothing but this is 8 meter per second. So correct answer is v2, that is 8 meter per second. This is the right choice. Is that clear? So like this is very simple question. Now let's see next question, that is question number 16. So you can see here annular disk has a mass of m, inner radius is small capital R and outer radius is 2r. The disk rolls on a flat surface without slipping. Means you can say, suppose you have a flat surface and this is a annular disk, this is disk. Correct, this is a disk 1, और obviously annular disk means ये हमारे पास hollow disk होगा. It is looking like this and the radius of hollow disk is smaller. So let's see, it is looking like this. Okay, so this is center, this is center. इस सेंटर से इसकी रेडियस कितनी है, कैपिटल R. इस सेंटर से इसकी रेडियस कितनी है, 2r. Yes or no? This is 2r. So कह रहा है कि if the disk is rolls on a flat surface, इस फ्लैट सरफेस में अगर इसको रोल किया जाए, इस फ्लैट सरफेस में अगर इसको रोल किया जाए तो इसकी काइनेटिक एनर्जी क्या होगी. Yes or no? So simply if we assume this is an elemental disk, बीच में होलो सेक्शन है, वहां पे कुछ भी मास नहीं है, एक एलिमेंट कंसिडर कर लिया जो कि किस रेडियस पे, स्मॉल रेडियस r पे है, इसके थिकनेस हम बोल देते हैं dr. Yes or no? करेक्ट. और इस एलिमेंट का जो मास है, लेट अस अज्यूम मास ऑफ एलिमेंट, इसका मास है dm. करेक्ट. तो क्या करें, एंड एनुलर डिस्क हैज अ मास ऑफ m. एनुलर डिस्क जिसका सपोज अगर मैं इसकी यूनिट थिकनेस मान लूं तो इसका मास क्या लिख सकता हूं मैं, मास ऑफ एनुलर डिस्क, जिसका एरिया क्या होगा, अगर मैं इसका एरिया लिखूं तो कहना है दिस इज नथिंग बट दिस इज पाई बाई 4. सॉरी, रेडियस के फॉर्म लिख रहा हूं तो दिस इज, इट कैन बी रिटन एज पाई 2 टाइम्स ऑफ r स्क्वायर माइनस r स्क्वायर. इस क्रॉस सेक्शन एरिया का ऑब्वियसली इनटू थिकनेस इनटू, और मैं g इन सबसे मल्टीप्लाई, डेंसिटी से मल्टीप्लाई कर दूं, देन यू विल गेट द मास m. दिस इज इक्वल टू मास m. तो सिंपली कह सकता हूं मैं कि इस एरिया के लिए हमारे पास मास क्या है, m. इज इट क्लियर? अब अगर मैं इस एलिमेंट के लिए लिखूं मास ऑफ एलिमेंट जो कि डीएम है, तो मैं इसको ऐसे लिख सकता हूँ क्या, एरिया ऑफ दिस डीएम इज नथिंग बट दिस इज 2 पाई आर इंटू डी आर। ये तो इसका एरिया हो गया, इंटू थिकनेस इंटू रो, इसको मैं ऐसे लिख सकता हूँ। तो देखो अननेसेसरी यहाँ पे हम इसको ढो के नहीं चलते क्योंकि इसका कोई यूज नहीं है। तो सिंपली वी कैन से दिस इज इक्वल टू मास एम एंड दिस इज, और इसका डीएम एलिमेंट का जो मास है, डीएम एलिमेंट का जो मास है वो क्या है, सॉरी एरिया है, इसको हम एरिया के फॉर्म में रिप्रेजेंट करते हैं। तो डीएम एलिमेंट, डीएम सॉरी जो हमने एलिमेंट कंसीडर किया उसका मास डीएम है, जो कि जिसका एरिया कितना है 2 पाई आर डी आर, करेक्ट। तो यहां से आप मुझे बता सकते हो, सिंपली कहना इसे पाई इज नथिंग बट दिस इज एम ओवर, ये क्या आएगा 4 r² माइनस आर स्क्वायर, सो सिंपली कहना इसे दिस इज 3 r²। और इसकी वैल्यू अगर मैं यहाँ पे पुट कर दूं तो डीएम मास ऑफ द डीएम एलिमेंट क्या आ जाएगा, दिस इज नथिंग बट दिस इज 2 इंटू एम ओवर 3 r² इंटू आर इंटू डी आर। ये सारनो इस तरीके से लिख सकता हूं। ये मुझे क्या है, एलिमेंटल मास डिस्ट्रीब्यूशन मिल गया विथ रिस्पेक्ट टू रेडियस। तो द मोमेंट ऑफ इनर्शिया, मोमेंट ऑफ इनर्शिया अगर लिखूं मास मोमेंट ऑफ इनर्शिया, तो कैन आई से दिस इज नथिंग बट दिस इज एम इंटू सॉरी डीएम इंटू r², ऐसे लिख सकता हूं। एंड व्हाट अबाउट डीएम, dm is nothing but, or simply you can say r² into dm is nothing but 2/3 m by r² into small r dr. Yes or no? So if you simplify this expression, so can I say this is nothing but 2m by 3r², इसको तो बाहर ले लो इंटीग्रेशन से, so simply here we can get r cube dr and its limit is varying from 0 to capital R. Yes or no? So after simplifying this, here we can get 2m over 3r² in bracket r to the power 4 by 4 and the limit is 0 to capital R. Yes or no? And once you put this capital R, so simply here we can get, and this is 4, so 2 by this is m r square by 6, क्या मिल जाएगा यहाँ से, m r², सॉरी, and this is not from 0 to 2r, this is also wrong. Actually radius is varying, this is the annular cylinder, yes, annular disk, so its radius is varying from r to 2r, so simply you put limit r to 2r. So if you put this limit on this expression, then I am directly writing, here we get 5/2 m r², correct. So I think are you getting how to write a moment of inertia of this annular disk? एनुलर डिस्क का मोमेंट ऑफ इनर्शिया लिखने के बाद अब आपको क्या करना है, सिंपली यू राइट काइनेटिक एनर्जी ऑफ द डिस्क इज नथिंग बट, तो आपको क्या में लिखना है, काइनेटिक एनर्जी ऑफ रोटेशन, जो कि मैं बार बार लिखते आ रहा हूं, प्लस काइनेटिक एनर्जी ऑफ ट्रांसलेशन। ये सानो करेक्ट, क्योंकि ये रोल भी हो रहा है और ट्रांसलेट भी हो रहा है, दैट्स व्हाई आई एम राइटिंग दिस। तो द टोटल काइनेटिक एनर्जी इज नथिंग बट सिंपली कैन आई से दिस इज, रोटेशन के लिए अगर मैं लिखूं तो हाफ ऑफ आई ओमेगा स्क्वायर, ट्रांसलेशन के लिए लिखूं तो क्या आएगा, हाफ ऑफ एम वी स्क्वायर। तो काइनेटिक एनर्जी इज नथिंग बट, यस आई इज नथिंग बट दिस इज 5/2 एम आर स्क्वायर इंटू व्हाट अबाउट ओमेगा स्क्वायर, सो कैन आई से दिस इज v²/r² प्लस ये सार नो, ये सार नो, इज इट क्लियर, ये समझ में आया कैसे लिख रहे हैं हम। So yes, one more thing. This is a 2r, है ना? You can say this is the outer radius. इसकी रेडियस कितनी है, 2r है। अब अगर मैं इसकी टेंजेंशियल वेलोसिटी v है, तो v इज इक्वल टू 2r इंटू ओमेगा लिख सकता हूँ। ऑब्वियसली फ्रॉम दिस वी कैन से ओमेगा इज इक्वल टू v/2r, so v²/4r whole square. So let me see if I correct this. So simply here we can get v² by 2r whole square plus half mv square. So what about kinetic energy? You can see if you simplify this, then 5 by 4 mr square into v square by 4r square plus half mv square. So this is cancelled out with this. So kinetic energy is nothing but this is 5 by 16 mv square प्लस हाफ ऑफ एम वी स्क्वायर. और इसको अगर हम सिंप्लीफाई करें तो क्या रिजल्ट मिलेगा? तो काइनेटिक एनर्जी इज नथिंग बट 16 is the LCM, so 5 plus 8 mv square. So simply here we can get 13 by 16 mv square. This is the kinetic energy of the particle, and this is the answer. Yes or no? So are you getting how to solve this? So simply here I am writing total kinetic energy is nothing but this is kinetic energy of rotation plus kinetic energy of translation. Correct? So rotation के लिए kinetic energy क्या होती है? हाफ I ओमेगा स्क्वायर. kinetic energy translation के लिए क्या होगा? तो simply we can say this is half mv square. अब यहाँ पे m पता है और ओमेगा हम यहाँ से कैलकुलेट कर लेंगे. From this omega is nothing but this is v by 2r. Yes or no? तो यहाँ से आप सिंपली कह सकते हो काइनेटिक एनर्जी इज नथिंग बट दिस. सिंपलीफाई करो एंड देन यू विल गेट द आंसर. So if I see from option, so option C is the right one. Okay, so let's see next question, that is question number 17. So a mass of m1 of 100 kg traveling with a uniform velocity of 5 meter per second. So if we see m1 is nothing but this is 100 kg which is moving with velocity, let's say its u1 velocity, initial velocity is 5 meter per second, along a line collides with a stationary mass m2 is equal to 1000 kg. After the collision both the mass travel together and obviously stationary है इसलिए इसका initial velocity क्या होगा? 0. एंड टकराने के बाद दोनों क्या एक साथ मूव कर रहे हैं. देन द कोफिशिएंट ऑफ रेस्टिट्यूशन इज, सो कैन आई से if I apply conservation of momentum, conservation of linear momentum, इसको अगर मैं अप्लाई करूं तो सिंपली इफ आई से m1 u1 प्लस m2 u2 इज इक्वल टू आफ्टर कोलिजन दोनों मास एक साथ मूव कर रहे हैं. सो लेट्स से m1 प्लस m2 इंटू v. So from this can I say v is nothing but m1 is nothing but this is 100 into u1 given है that is 5 meter per second and यहाँ पे u2 जीरो होने की वजह से टर्म जीरो हो जाएगा ओवर 100 प्लस m2 कितना है 1000. तो सिंपली here we get 500 over 1100. So 5 by 11, this is its final velocity. So once we will get final velocity, so coefficient of restitution is nothing but this is the ratio of velocity of separation over velocity of approach. Is it clear? Velocity of approach. So velocity of separation is nothing but this is v and velocity of approach is nothing but this is u1. Why I am writing like this? Because u2 already 0 नहीं तो otherwise यहाँ पे u1 minus u2 लिखता. So simply v is given that is 5 by 11 and what about u1 that is 5. So when you simplify this then you will get 1 by 11. Yes or no? And if you solve this then here we get so let's see. A mass of m1 is equal to 100 kg traveling with uniform velocity 5 meter per second along a line of collide with a stationary mass m2 is equal to 1000 kg. After the collision, both the mass travel together with the same velocity. Oh, both the mass travel with the same velocity. So why I am using this? So let's see if I correct this. After collision, both mass can travel with same velocity. So let's say, can I write m1 into v plus, sorry, m2 into v. So obviously after solving this, you will get v2 is equal to 5/11. मैं डायरेक्टली लिख रहा हूँ क्योंकि हमने प्रीवियसली इसको ऑलरेडी सॉल्व कर लिया था, या फिर से चलो लिख देता हूँ, डोंट वरी अबाउट दिस. मैं इसको उड़ा देता हूँ, जस्ट वेट. यस. So actually while writing this, velocity of separation is nothing but this is v2 minus v1, not v. And velocity of approach is nothing but this is u1 minus u2. Yes or no? And obviously दोनों जो पार्टिकल है सेम वेलोसिटी से मूव कर रहे हैं, तो मैं यहाँ से कह सकता हूँ v1 इज इक्वल टू v2, दिस इज इक्वल टू v. और इस तरीके से अगर दोनों सेम वेलोसिटी से मूव कर रहे हैं तो हमारे पास कोएफिशिएंट ऑफ रेस्टिट्यूशन क्या आ जाएगा, 0. तो द करेक्ट आंसर इज ऑप्शन डी. डोंट मेक मिस्टेक यहाँ पे u अपॉन u1 माइनस v अपॉन u1 माइनस u2 लिखना. इज इट क्लियर? ये रॉन्ग हो जाएगा. Okay, so this is question number 17. So let's see next question, that is question number 18. Question number 18, you can see here. So in a single degree of freedom system having mass 1 kg, stiffness 10 kg. So यहाँ पे आपको single degree of freedom दिया है, mass है उसका 1 kg, stiffness is already given here, that is 10 kilonewton per meter. Initially at rest means u1 is equal to 0 है. Subjected to an impulse force of magnitude, impulse force, let's say this is if, this is impulse force which is equal to 5 kilonewton for t is equal to 10 to the power minus 4 second. The amplitude in millimeter of the resultant free vibration is, so can I say this Newton from Newton's second law, this is nothing but m into del v by del t. Correct? So from this, can I say f dt is equal to m dv? Yes or no? M dv. Yes or no? So now if we integrate from t1 to t2 and similarly from its initial velocity v1 to v2, so here we get 5 into 10 to the power 3 into 10 to the power minus 4 minus 0. This is equal to m times v2 minus v1, and v1, this is not u1, this is v1. Let's say this is v1. v1 to 0 है already. So from this, can I say v2? Mass is already given here, that is 1 kg. If you put, then from this you will get v1 is equal to 0.5 मीटर पर सेकेंड. इस तरीके से आपको v2 मिल जाएगा. And once you will get v2, simply if I equate kinetic energy mv square is equal to free energy stored in the spring, that is half kx square. So from x, can I write this is nothing but this is mv square by k. Is that clear? So from this, if I put mass m, this is 1 and this is v2 obviously, which is 0.5 whole square over k. K is nothing but this is 10 kilonewton per meter. So can I say this is 10 into 10 power 3. So if you simplify this, then you will get 0.05 meter. Sorry, 0.005. I'm not calculating, you just calculate it. Yes or no? 0.005 meter. Or simply you can say this is equal to 5 millimeter. 5 millimeter. So the correct answer is x is equal to 0.5. So, sorry, 5 millimeter. So option C is the right choice. Yes or no? Option C is the right choice. Okay, so now Next question, that is question number 19. So a stone with mass of 0.1 kg is capsulated as shown in the figure. The total force Fx in Newton is exerted by the rubber band as shown in the function x. Fx हमें function के form में दे दिया गया है, that is 300 into x square. If the stone is displaced by, displacement is given, that is 0.1 meter from the unstretched position when x is equal to 0 of the rubber band, the energy stored is, so energy is nothing but, can I say energy is nothing but this is equal to fx, f is a function of x, fx into dx. And now if you integrate from 0 to 0 to 0.1, this is the displacement range, so we will get the answer. So fx is given as, that is 300x square into dx, and the limit is 0.0 to 0.1. And if you integrate, then simply here we get 300 into x cube by 3, and the limit is 0 to 0.1. So now if you put this value, then obviously here we can get 300, sorry, this 300 by 3, that is 100 into 0.1 cube. So simply here we can get 0.1 joule. 0.1 joule. This is the answer. Yes, option B is the right choice. Is that clear? Next, question number 20. The coefficient of restitution of a perfectly plastic impact is perfectly plastic impact. So obviously the answer is 0. Yes or no? For perfect plastic we have E is equal to 0. And similarly for perfect elastic we have E is equal to 1. For perfect elastic collision we have E is equal to 1. और inelastic collision होगा तो यहाँ पे क्या होगा वैल्यू, and you see E is always varying from 0 to 1. Is that clear? And this is question number 21. During inelastic collision, you can say during inelastic collision of two particles, which one of the following is conserved? Total linear momentum only. This is inelastic collision. Total kinetic energy only. Both linear momentum and kinetic energy, and neither linear momentum nor kinetic energy. So you say in inelastic collision only total linear momentum is conserved. Is that clear? So option A is the right choice. Okay, so let's see next question, that is question number 22. So in this we have a 1 kg mass of clay moving with a velocity of 10 meter per second. So let's say if m1 is equal to 1 kg and its initial velocity is 10 meter per second, strikes stationary wheel and stick to it. मतलब इसको जब आप यहाँ से थ्रो करोगे और जब इससे टकराएगा तो इसी के ऊपर स्टिक हो जाएगा, करेक्ट है. And the mass of the solid wheel is let's say 20 kg, करेक्ट. और इसका जो इनिशियल वेलोसिटी है दिस इज 0 बिकॉज ये स्टेशनरी है, एंड इसका रेडियस भी गिवन है दैट इज 1 मीटर. आफ्टर क्या होगा कि व्हेन यू move this clay, when you throw this clay on the wheel, then obviously it moves with velocity 10 meter per second, and after collision is sticked onto the wheel, and both after that, assuming that the wheel is set to be into pure rolling motion, and after that when it collides, then this the mass along this clay with this wheel can rotate with angular velocity of the wheel. So you need to find out ओमेगा कि जब ये टकराएगा तब उस टाइम इसकी एंगुलर वेलोसिटी क्या होगी. इज दैट क्लियर? So if I apply this is conservation of linear momentum, so can I say initial momentum is equal to conservation of angular momentum. Is that clear? Because यहाँ पे जब भी रोटेशन आएगा तो समझ जाना यहाँ पे कंजर्वेशन ऑफ एंगुलर मोमेंटम अप्लाई करना है. तो फ्रॉम conservation of angular momentum, conservation of angular momentum, if we apply, then can I say Li is equal to Lf? Yes or no? And Lf क्या होगा? Lf, let's say this point is O. सपोज अगर ये पॉइंट ए है जिसके अबाउट ये रोल हो रहा है, तो Lf अबाउट पॉइंट ऑफ कॉन्टेक्ट ऑफ रोलर एंड द सरफेस, जो कि क्या होगा, दैट पॉइंट इज ए. यस और नो? अगर मैं इसको इस तरीके से लिखूं तो सिंपली यू कैन सी हियर, simply you can see here Li is nothing but initial momentum is nothing but this is mvr, correct? और Li is nothing but m is क्या है यहाँ पे, इनिशियल 1, वेलोसिटी क्या दिया हुआ है, 10 मीटर पर सेकेंड से मूव कर रहा है, एंड लेट्स से रेडियस 1, सो दिस इज इक्वल टू 10, करेक्ट? मतलब जो ये क्ले है इसके ऊपर टकराएगा तब इसका एंगुलर मोमेंटम क्या होगा, दिस वन. क्यों? क्योंकि ये जो मूव कर रहा है एट ए वेलोसिटी एट ए रेडियस ऑफ r इज इक्वल टू 1 मीटर, correct? And if I write final momentum, then simply can I say this is mvcm, velocity of center of mass into r plus I omega, correct? So mass यहाँ पे, if I neglect the mass of the clay, and simply we can say 20 into vcm. vcm क्या हो जाएगा, सेंटर ऑफ मास. देखो, लेट्स से सपोज यू हैव अ डिस्क और ये सेंटर ऑफ मास है और सेंटर ऑफ मास की वेलोसिटी v है, तो सिंपली मैं क्या लिख सकता हूँ, v इज नथिंग बट दिस इज r ओमेगा, करेक्ट? सो सिंपली इट कैन बी रिटन एज 20 into r ओमेगा into r प्लस m, और ये डिस्क है तो mr स्क्वायर बाई 2 into ओमेगा. दिस इज फाइनल मोमेंटम. Is it clear? And if we apply conservation of momentum, then simply we can write Li is equal to Lf, which is equal to 10 into the radius is given, that is 1. So simply we can say 20 into 1 into omega plus mass is 20 by 2 into 1 into omega. So from this simply here we can get 20 omega plus 10 omega, that is 30 omega is equal to 10. So omega is nothing but this is 10 by 30. This is equal to 1 by 3 radian per second. Correct? So the correct answer will be 1 by 3. That is option B. करेक्ट? तो सिंपल से यहाँ पे हमें क्या लिखना है, जब भी रोटेशन की बात होगी तो यू मस्ट यूज कंजर्वेशन ऑफ लीनियर मोमेंटम, सॉरी कंजर्वेशन ऑफ एंगुलर मोमेंटम, नॉट लीनियर मोमेंटम. यस आर नो? आपको एंगुलर मोमेंटम यूज करना है, ना कि लीनियर मोमेंटम. यस आर नो? ओके, सो लेट्स सी अनदर प्रॉब्लम, एंड यू कैन से दिस इज अ क्वेश्चन नंबर 23. So in this question you can see an elevator that is lift consists of the elevator cage and a counterweight. ये counterweight है, this is cage and this is counterweight. The cage and the counterweight are connected by a chain. Both are connected by a chain. It means दोनों में tension same होगा. That pushes over a pulley. The pulley is coupled to a motor. This pulley is coupled with a motor. It is desired that the elevator should have a maximum stopping time of t second from a peak speed v. If the inertia of the pulley and the chain are neglected, the minimum power required, the power that the motor must have. So motor की यहाँ पे power निकालनी है. So can I say in this power होता क्या है? तो power is nothing but rate of change of energy. Yes or no? Rate of energy supplied, can I say? Rate of energy supplied is called power. So the power is nothing but the total energy, the total energy absorbed over time, इस एनर्जी को एब्जॉर्ब होने के लिए कितना टाइम लिखा, दैट इज टाइम। तो टोटल एनर्जी क्या होगा, दैट इज टोटल काइनेटिक एनर्जी, दैट इज हाफ ऑफ mv स्क्वायर प्लस हाफ ऑफ, दोनों साइड क्या है, मास m और यहाँ पे भी मास m है, और दोनों सेम वेलोसिटी से, एक ऊपर जा रहा है एक नीचे आ रहा है, तो सिंपली कहने से दिस इज हाफ ऑफ टोटल चेंज इन काइनेटिक एनर्जी क्या हो जाएगा, दैट इज हाफ ऑफ mv square plus half of mv square, and for this it take time t. So can I say this is nothing but this is mv square by t, mv square by t. So the correct answer is option C. Okay, so let's see next question, that is question number 24. Question number 24. So in this, an ejector mechanism consists of a helical spring. You can see this is a spring having a spring constant k is given here. K is given here, that is k is equal to 981 into 10 to the power 3 Newton per meter. It is pre-compressed by 100 mm from its free state. Means initial जो ये spring है ये compressed है by an amount of 100 millimeter. Correct, 100 mm से compressed है. If it is used to eject a mass of 100 kg, let's say mass जिसको हमें eject करना है उसका mass है 100 kg. Held on it, the mass will move up through a distance. So हमें देखना है कि जब मैं स्प्रिंग को रिलीज करूंगा तो ये कितनी हाइट तक इस मास को थ्रो कर रहा है, yes or no? So can I say the kinetic energy is nothing but this is half mv square, yes or no? Half mv square, and स्प्रिंग में जो एनर्जी स्टोर हो रही है दैट इज स्ट्रेन एनर्जी यहाँ पे जो स्टोर हो रही है स्प्रिंग में दैट इज कॉल्ड एज हाफ के एक्स स्क्वायर, यस और नो? तो यहाँ पे हम दोनों को इक्वेट कर सकते हैं, स्ट्रेन एनर्जी इज इक्वल टू हाफ ऑफ mv स्क्वायर, सॉरी काइनेटिक एनर्जी, yes or no? So simply can I say this is half of kx square is equal to half of mv square. So this is cancelled out. So simply v is nothing but it can be written as kx square by m square root, yes or no? तो अगर मैं यहाँ पे वैल्यू पुट कर दूँ तो k क्या है यहाँ पे 981 इंटू 10 टू द पावर 3 और x ये न्यूटन मीटर है और 100 मिलीमीटर है तो 0.1 स्क्वायर ओवर मास दैट इज 100 kg. तो यहाँ से आपको वेलोसिटी मिल जाएगा कि किस वेलोसिटी से जो मास है वो इजेक्ट हो रहा है. एंड फ्रॉम आफ्टर अप्लाइंग दिस सिंपली वी नीड टू राइट v स्क्वायर from Newton's second law, v square is equal to u square plus 2as. Initial velocity is 0. Initial velocity is 0. Yes or no? So simply can I write s is equal to v square over 2as. And what about a? You can see here this mass is moving in the upward direction with acceleration a, and gravitational acceleration is acting downward. So can I say this is a is equal to a is equal to minus g, yes or no? So if I use this relation, so simply we can put this value here and we get v square over 2 into minus g, yes or no? So s is equal to v square. So if I write v square, so can I say this is 9.81 into 10 to the power 3 into 0.1 square over 2 into minus 9.81, yes or no? So this is cancelled out with this. So if you simplify this, then you will get s is equal to minus, and this is 10 by 2, that is minus 5 meter, yes or no? This is 5 meter, or you can say s is equal to minus 500 millimeter. और नेगेटिव साइन क्या बताता है कि ये जो मास है ये इजेक्ट होके कहाँ जाएगा, अपवर्ड डायरेक्शन में, ऊपर की तरफ जाएगा. इज इट क्लियर? दैट्स व्हाई इट इज रिटन हियर minus n. So correct answer is 5000 millimeter. Okay, so let's say next question, that is question number 25. A bullet of m mass travels at a very high velocity, correct, p s1 in the figure, and the gets embedded inside the block. मतलब ये जो बुलेट है इसके अंदर धंस जाएगी. Initially at the rest on a rough horizontal floor, the block with the bullet is seen to move a distance s along the floor, assuming mu to be coefficient of the kinetic friction between the block and the floor. G is the acceleration due to gravity. Then what is the velocity of the bullet? So obviously you can see here, यहाँ पे आप देखो, जो सपोज बुलेट का जो मास है वो m है. दिस इज अ बुलेट, correct, whose mass is m and it is moving with velocity v. और यहाँ पे एक ब्लॉक रखा हुआ है जिससे ये टकराने वाला है, जिसका मास है कैपिटल M. ये सारों, तो ऑब्वियसली जब ये बुलेट इसमें टकराएगा देन दिस मास इज ट्राइंग टू मूव अलोंग दिस डायरेक्शन विथ वेलोसिटी u, और इसका डिस्प्लेसमेंट इस डायरेक्शन में है, ये सारों, और इसमें नॉर्मल रिएक्शन अपवर्ड लगेगा और फ्रिक्शनल फोर्स समवेयर ईयर लगेगा. ये सारों करेक्ट. तो नेक्स्ट अगर मैं यहाँ पे लिखूँ द फॉर्म कंजर्वेशन ऑफ लीनियर मोमेंटम, conservation of linear momentum, conservation of linear momentum, then simply can I say this is nothing but this is mv is equal to, ये आपका इनिशियल वेलोसिटी से मूव कर रहा है, और m प्लस कैपिटल M. अब ये बुलेट जो है इसके ऊपर पेनिट्रेट हो गई है, इसके ऊपर एम्बेडेड हो गई, धस गई है, और ये मूव कर रहा है विथ लेट्स से विथ वेलोसिटी u. ये सारों, तो सिंपली u क्या लिख सकते हैं, mv ओवर m प्लस कैपिटल M. ये सारों, तो इस वेलोसिटी से मूव कर रहा है. तो इफ आई टॉक अबाउट काइनेटिक फ्रिक्शन की अगर बात करें, क्योंकि ये बॉडी मूव कर रही है, तो इफ आई यूज काइनेटिक फ्रिक्शन, तो कैन इट से काइनेटिक फ्रिक्शनल फोर्स, let's say this is ffk. So can I say ffk is nothing but this is kinetic coefficient of friction into normal reaction. Yes or no? And kinetic friction is already given here, that is mu, and n is given, that is m plus capital M into g. Let's say this is equation 1, this is equation 2. So now if I apply equilibrium condition, you can see here from this figure. So can I say ffk is nothing but this is mass into acceleration, yes or no? And what mass? Total mass, yes or no? So this is m plus capital M into acceleration. So simply can I say, so from this A is nothing but, और ये दोनों फोर्स क्या होंगे, ff already here we know, that is mu times of m plus capital M into g. So can I say acceleration is nothing but this is mu g. Let's say this is equation 3rd, yes or no? So you will get acceleration, and after getting acceleration, so can I say if I apply this relation, Newton's second law, v square is equal to u square plus 2as. So simply as you see here, obviously the velocity of the bullet is 0. So sorry, the final velocity of the bullet is 0. This is equal to 0, equals to u square minus 2as. And obviously you can see both are acting in opposite direction. So can I say this is, if I represent in the vector form, so can I say this is nothing but this is of minus I cap. Yes or no? f को हमने पॉजिटिव कह दिया तो ऑब्वियसली ये नेगेटिव आएगा. So can I say this is minus of 2 into a is nothing but this is mu g, और mu क्या है यहाँ पे, kinetic coefficient of friction into s. So s is nothing but this is u square over 2 mu g. Yes or no? And what about u? U is nothing but this is m plus capital M is divided by small m into v. Sorry, let's see. Yes, into a small v into this is the u square. So this is square over 2 times of mu g. So S is nothing but it can be written as, so from this we simply use, you can say this is v square. So can I write this is, actually we need to find velocity. So v square is nothing but this is 2 mu g into S over m plus capital M by small m whole square. So simply if you simplify this relation, so here we get v is equal to square root of 2 mu g s into m over small m plus capital M. So this is our final velocity. This is our final velocity. Yes or no? So from this, if in this option, if I see which one is the correct answer, so you see 2 mu gs, 2 mu gs. This is m plus capital M by, this is wrong. So m plus m by m, this is not small m by capital M plus small m into root 2 mu gs. And this is minus, I think this is wrong. This is a plus sign. This is a plus sign, correct? Oh, sorry, not plus sign. This is negative. So out of this, none of the option can. Okay, so let me see. Oh, here I make mistake. Actually, this is small m over capital M plus small m whole square. Yes, I found this mistake. So now if I correct, then here we get uh, m over capital M plus small m whole square. Now if we simplify this, then here we get square root of 2g mu s into m plus capital M by small m. This is the right option. This is the right option. So let's see in the option. So m plus m by m root square root of 2 mu gs. Yes, option A is the right choice. Option A is the right choice. So like this you can solve this question. Okay, so now let's see another question. Match the following from list 1 to list 2. So collision of particle, stability, satellite motion, spinning top. So you can see, if I talk about collision of particles, here we use impulse momentum principle. Yes, so A4, correct? A4, conservation of momentum. No, satellite motion. If I talk about satellite motion, then which option is the right? Sorry, stability. If I talk about stability, and you see when for whenever we have stability, equilibrium, इस तरह के कोई भी term हो, then we always gives us minimum potential energy. जब एनर्जी मिनिमम होगी तभी स्टेबिलिटी आएगी, तो ऑप्शन 3 होगा और बी. तो 4-3. अब नेक्स्ट आता है सैटेलाइट मोशन. तो सैटेलाइट मोशन क्या हो सकता है? यूलर इक्वेशन ऑफ द मोशन, मिनिमम काइनेटिक एनर्जी. दिस इज एब्सोल्युटली रॉन्ग. कंजर्वेशन ऑफ मोमेंटम, नो. So Euler's equation of motion is applicable for satellite motion. And if I talk about spinning, so option 5th is the only option for this. That is conservation of momentum. So option D is the right choice. Okay, so let me see. This is question number 26. And next, this is question number 27. a ball A of mass capital M falls under gravity from a weight from a height h and strikes another ball B of mass M which is supported at rest on a spring. So if I write its condition, so here we have a ball A and similarly here we have a ball B which is connected with the spring. इससे connected है ये. Yes or no? अब बॉल A of mass M, इसका मास है M और कहाँ से ये स्ट्राइक हो रहा है? फ्रॉम हाइट h. So let's see h. So can I say the velocity of the ball A before collision is nothing but this is root 2gh. Yes or no? और ये मास B मास से टकरा रहा है जो कि सपोर्टेड और रेस्ट कंडीशन में है. तो कैन आई से इट्स इनिशियल वेलोसिटी ऑफ पार्टिकल B इज 0. बॉल B 0 एट रेस्ट ऑन स्प्रिंग ऑफ द स्टिफनेस के अज्यूमिंग परफेक्ट इलास्टिक कोलिजन. यहाँ पे क्या हो रहा है? परफेक्ट इलास्टिक इम्पैक्ट हो रहा है. इमीडिएटली आफ्टर द इम्पैक्ट वेलोसिटी क्या होगी? assume perfect elastic impact immediately after the impact. So simply can I use in this, can I use this is a perfect elastic collision, so simply we have E is equal to 1. So velocity of separation over velocity of approach, ये होता है हमारा coefficient of restitution. Yes or no? So can I say this is v2 minus v1 is equal to u times 1, or simply you can say u, or this is nothing but this is root 2gh. Correct? ऐसे लिख सकते हैं. And you can see I am using 1 for ball A and 2 for ball B. Correct? So this is actually u1 and u2 0 है तो यहाँ पे मैंने इसलिए लिखा नहीं. Is that clear? So next see, if I apply conservation of momentum, conservation of linear momentum, conservation of linear momentum. So can I say this is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Yes or no? और दोनों का मास यहाँ पे देखो सेम है. So simply can I say v1 plus v2 is equal to u1, and this is equation 2. This is equation 1. Yes or no? So from both the expressions, यहाँ पे हम कह सकते हैं from equation 1 and 2, इन दोनों इक्वेशंस को अगर मैं अप्लाई करूं तो सिंपली मैं क्या लिख सकता हूं? तो इन दोनों को इक्वेट कर दो. ये दिस इज u1 एंड दिस इज u1. सो सिंपली कैन आई से v2 माइनस v1 इज इक्वल टू v1 प्लस v2. और अगर मैं इसको सिंप्लीफाई करूँ तो क्या रिजल्ट आएगा? देखो यहाँ से हमें मिल जाएगा 2 टाइम्स ऑफ v1 इज इक्वल टू 0. सो सिंपली वी कैन से v1 इज इक्वल टू 0, और v1 इज इक्वल टू 0 मिल गया तो v2 इज इक्वल टू क्या मिल जाएगा? u1, दैट इज रूट 2gh. यस और नो? करेक्ट. तो हमारा आंसर क्या होगा? लेट्स सी द ऑप्शन. द वेलोसिटी ऑफ बॉल ए इज हाफ ऑफ स्क्वायर रूट ऑफ दिस. रॉन्ग आंसर. द वेलोसिटी ऑफ बॉल ए इज 0. yes, it is right. The velocity of both the balls, color, none of the above. So correct answer is option B. Velocity of the ball A is 0. You can say this is the velocity of ball A. Is that clear? Okay, so let's say this is another question. That is question number 28. A pin jointed uniform resistor rod of weight W and the length L is supported horizontally by an external force F as shown in the figure. The force F is suddenly removed at the instant of the force removed. The magnitude of the vertical reaction W at the support is. तो देखो इनिशियली अगर मैं इसकी इनिशियल कंडीशन ड्रॉ करूं तो कैन आई से इनिशियली इस एंड पे आपको हॉरिजॉन्टल रिएक्शन मिलेगा. लेट्स से दिस इज आर एच, यहाँ पे एक वर्टिकल रिएक्शन मिलेगा दैट इज आर वी, और इसमें एक हम यहाँ पे सपोर्ट लगा रहे हैं जिसमें फोर्स एफ लग रहा है, और इसका खुद का वेट जो है वो सेंटर पे एक्ट होगा दैट इज एल बाई टू डिस्टेंस पे डब्ल्यू। तो अगर मैं इसके लिए लिखूं समेशन ऑफ हॉरिजॉन्टल फोर्स इक्वल टू जीरो, तो यहाँ से एक रिएक्शन मिल गई आर एच इज जीरो। समेशन ऑफ वर्टिकल रिएक्शन इज इक्वल टू जीरो लिखूं तो क्या इक्वेशन बनेगा, आर एफ वी प्लस एफ इज इक्वल टू डब्ल्यू। करेक्ट, एंड लेट अस सपोज दिस इज इक्वेशन वन। इज इट क्लियर? ऐसे लिख सकता हूं। एंड नाउ अब हम क्या करते हैं, ये कंडीशन है जब फोर्स एफ लग रहा है। नाउ इफ एफ इज रिमूव्ड, अगर एफ फोर्स को रिमूव कर दिया जाए, एफ फोर्स को रिमूव कर दिया जाए, तो दोस्तों क्या आएगा, ऑब्वियसली दिस रॉड स्टार्ट रोटेशन, देन हियर वी विल टेक टॉर्क, एंड टॉर्क इज नथिंग बट दिस इज आई अल्फा, यस आर नो। तो कैन आई से टॉर्क इज नथिंग बट ये इसका टोटल वेट सेंटर पे लाई करेगा दैट इज डब्ल्यू। मतलब ये ऐसी सिचुएशन होगी, यहाँ पे वर्टिकल रिएक्शन मिल रहा है आर बी, यहाँ पे इसका वेट डब्ल्यू लग रहा है, और कितने डिस्टेंस पे एल बाई टू। तो टॉर्क जो आएगा क्या आएगा, डब्ल्यू इंटू एल बाई टू इज इक्वल टू मोमेंट ऑफ इनर्शिया रॉड का क्या होगा, एम एल स्क्वायर बाई 12, सॉरी एम एल स्क्वायर बाई 3 इंटू अल्फा। और m क्या होगा यहाँ पे, ऑब्वियसली w इज इक्वल टू एम जी होगा, तो m इज इक्वल टू डब्ल्यू बाई टी। तो सिंपली कैन आई राइट w इंटू एल बाई टू इज इक्वल टू w बाई जी इंटू एल स्क्वायर इंटू दैट इज दिस इज ओमेगा नॉट w by 3, yes or no? So after simplifying this, so here we get w is equal to यहाँ से क्या रिजल्ट मिल जाएगा, this is L square and this is L, so this is cancelled out with this, so 3 by 2 L. And now if I write let's say suppose acceleration about its center of gravity, so can I say this is nothing but this is L by 2 times of angular acceleration, yes or no? So from this w minus rv is equal to w minus rv is equal to nothing but, अब हमारे पास क्या है, f नहीं है, ओनली वी हैव दिस इज w एंड हियर वी हैव rv। इस कंडीशन में हम कह सकते हैं नेट फोर्स इज इक्वल टू मास इंटू एक्सीलरेशन अबाउट सेंटर, mass into acceleration about center, and if we can apply this relation, so simply we get instead of w minus rv, you can see from this expression, can I write instead of w minus rv, this is equal to w, sorry, rv plus f is equal to w, and here w minus rv is equal to m into ac, and m into acceleration about center of mass, correct? So this is nothing but this is w by g, m की जगह हम क्या लिखेंगे, w by g इंटू ए सी क्या आ जाएगा, दिस इज एल बाई टू इंटू अल्फा। तो दिस इज अवर नेक्स्ट एक्सप्रेशन। लेट मी सी, first here I am writing, actually here I make mistake, so can I here I am now correcting it. So this is w into L by 2, this is torque, and this is alpha, not, sorry, this is alpha, this is not omega. So can I say that is I is nothing but this is equal to w by g into L cube by 3 into alpha. Is it clear? So this is an expression 2 and this is an expression 3. So from using these two expressions, and suppose if I write thing, correct, so So now you can see here, if I simplify equation 2 and 3 from simply, can I write from equation 2 and 3, after solving these two equations, we get RV is equal to L by 4. Sorry, W by 4, not L by 4. तो आप इन दोनों इक्वेशंस को सिंप्लीफाई करके RV की वैल्यू पता कर सकते हो. So this is the answer. Okay, so let's see another question, that is question number 29. So in this question here we have, if a system is in equilibrium and the position of the system depends upon many independent variables, then the principle of virtual work states that the partial derivative of the total potential energy with respect to each of the independent variable must be. The correct answer is 0. मैंने आपको बताया था for equilibrium के लिए क्या होना चाहिए, द पोटेंशियल एनर्जी should be minimum, correct. And similarly हम कह सकते हैं if potential energy is a function of several independent variable, we don't know the variables, so IV means this is independent variable. So for minimum energy, for minimum potential energy, can I write del P by del of independent variable, that is partial derivative of potential energy with respect to independent variable, that should be equal to 0. So the correct answer is 0. Correct. So this is all about the question from virtual work and principle of momentum.